All right, hello, Peter. It's too bad we couldn't, do this live, but this will work. This works fine. Maybe we can try another live session later on. Before I delve into my responses and this back and forth, I want to make sure that we're all on the same page. I don't think we're going to agree with everything, at least not to begin with, and that's okay. That's normal. I'm not criticizing you because I maybe have different thoughts about how all of this could go. That's what this is all about. Let's just exchange ideas, right? I'm going to represent the mainstream science, STEM education perspective, and sometimes I will neglect to say that. I will be speaking occasionally as if I'm some kind of authority or as if this is just undisputable fact, when really all I'm saying is that this is the science that we're told. This is what I'm working with, and maybe you're exploring outside that range. So I'm not going to close my mind to anything you have to say, or any contrary thoughts you have of how the world works. But so please understand when I say, and I'm sure I'm going to say something like, that's not how this works. It works this way. I'll be speaking in absolutes. I do not mean absolute. I mean, we are taught that, we understand that, experiments have shown that, and of course we always must remain open to being corrected about something, and I do remain open to that. Okay, so with that out of the way, let's hear your questions and I'll respond.
Well, yours seems to be going no procession. Is there any doubt of the existing ones out there and on display? A fair question. No malice meant with it, just a curious mind at work. I'm not ready to make a call yet. I think I'm 20 experiments off that yet, so.
I think that's a fair answer, and I completely agree in all respects. Let's keep doing experiments. The longer you're willing to do these experiments, the happier I'm going to be about it, and the more we can all learn about it.
Magnetic gyro compasses, in fact, show the Earth is spinning in processes. Well, yeah, hey, they do. Except they're made from metallic componentry. Now, I'm waiting for the ceramic or the zirconium turbine one to be made.
Quick correction here. When I say gyro compass, the gyro compasses I'm speaking of are not magnetic gyro compasses. They are, it's not a magnetic compass. There's a magnetic compass, there's a gyro compass. Gyro compass works purely off the rotation of the Earth, and it doesn't have anything to do with magnetism as far as we understand. So I point that out because some people have the misunderstanding that it is a magnetic phenomena that is guiding those, and it is not. Magnetic compass points to magnetic north. A gyro compass points true north, or true south in your case. And it does that based on the spin of the Earth, as you understand. Now, you point out that they're metallic. Yeah, yes, I mean, they are, right? Never heard of anyone trying to make one out of a non-metallic substance. But it sounds like you have heard of somebody doing that, so that would be cool, certainly cool. From that brings me to this understanding that you have a hypothesis, or you have some idea that the precession that we're seeing may be due to some properties of a metal. Now, magnetism, of course, comes to mind as a property of certain metals, of iron particularly. Iron and steel are ferromagnetic, and the Earth has a magnetic field. you think those are interacting in some way, and how does that interaction relate to a gyro compass? I don't know how that relates. And what about non-ferrous metals like aluminum? Aluminum and lead often used in these things. Brass, like we've talked about, the pendulum at Griffith Park is brass, which is a non-magnetic metal. Is there some? Are you proposing that perhaps there's some other force exerted upon metals that may be relevant to this conversation? Something maybe that I haven't thought of, or perhaps maybe even science hasn't recognized. Does that not then open up a wealth of possibilities of experiments we can do based on that? If your theory is, or your, I should say hypothesis, is that these effects are caused by metal, we could try, doing things with metal and non-metal and side by side them, A/B test that as the independent variable. Does the metal cause this? And we could get directly to this mysterious force more quickly, perhaps, by focusing on that question, or eliminate that as a possibility. For example, that immediately brings to mind the test. I know you have tested some metal weights for your system, and you're using a glass one at this time. Why not swap out the metal? Why not swap out the glass for one of the metal ones, and just rerun the experiment and show? Is it consistent that the metal one processes and the glass one does not? That would be quite an interesting finding that would give us a clue along those lines.
Again, with optical gyros, wow, these are almost affordable now for the average person. They come down in price, and without question, they show precession of the Earth. Very accurate. But we still not have measured the speed of light. So why are we entertaining this? This is not even, cross this one out. This is just, no, don't go there.
Okay, hold on now. When you say we haven't measured the speed of light, are you suggesting you personally have not measured the speed of light? It's not like it's an unknown. Measurements of the speed of light have been done to extreme precision. Scientifically now, we understand the speed of light. So when we say we haven't measured the speed of light, that seems, I don't understand what you mean, unless you mean you personally haven't gotten to that step yet, and which is fair. We have not measured the speed of light yet doesn't feel to me like a legitimate reason to discount those results. Doesn't seem fair, right? That doesn't seem fair to me. But yeah, we could certainly say, let's hold off on optical gyros until you can reproduce them on your own, or something like that. Is like focusing on things we can do ourselves is important to start with. Okay, fair enough, right? Fair enough. We can focus on things we can do ourselves, and we could buy an optical gyro, particularly a used one. There's even kits. There are people who sell kits where you can make your own. We could maybe put that on the list for sometime later. Personally, my standpoint is it's a commercially available product. It is vouched for by scientists, pilots, navigators all over the world, and it's vouched for by flat earthers and by name of Bob Nodell, who sadly is not with us anymore. But I don't think we should question whether it's true or not. You would now be in a position of trying to suggest there is some cause for that rotation other than rotation of the Earth, that the the speed we measure from the optical gyro that matches the gyro compass and the other things. I don't think mechanical gyroscope is on your list, but something we discussed. All these things agree, so with the same number. So are we proposing that they all have the same other interaction, something that is not just the rotation of the Earth that affects them? And if so, what is that, and how could we measure that? How could we test for it?
You said, have you looked at Critical Think's channel? He's doing various weight measurements throughout the world, and he's got a lot of people on his side doing these, helping him out. Great. Is he using metallic weights? And I believe the measurements are static. Now, as you know from my ramp experiments, the measurements have to be made dynamic. We cannot do static measurements on weights.
All right. First answer, yes, his weights are clearly metallic. I'm not sure what metal they are. They look like stainless steel, but they could be lead weights clad with steel. That's pretty common too, I think. The steel being magnetic. Why does that have anything to do with the question? I don't know. You're suggesting that perhaps it does, that there's some kind of magnetic influence to metals in particular that causes metals to create the exact curve predicted by rotation that is not actually rotation, it just happens to line up. Certainly, we could ask Critical Think to switch to a non-metallic weight. That's doable. And I imagine he's a very nice guy. He's very into this stuff. He'd probably be willing to do that. As far as your dynamic versus static question, there you have really taken a left turn from mainstream science on that one. I have not really watched your ball bearing tests where you talk about static versus dynamic weight. I will say from my classical science education that we would measure weight. We can measure weight statically. We absolutely can and do measure weight statically. You stand on your bathroom scale and you weigh yourself. You don't jump up and down on the scale or you'll get a jacked up measurement, right? You need to be static and still to measure the constant force as a steady value. That needs to be static. The weight, specifically, weight is the amount of force being pushed down on a mass through gravity. That is what weight is. Now, to measure inertia, inertial things, we would definitely want to use a dynamic test. And mass equally influences inertia as it does influence weight. We have found that time and time again. That's a known thing. So when you say it has to be dynamic, I don't understand why you assert that. You would absolutely have to tell me more. Maybe I can go and watch your videos and get a better understanding of where you're coming from on that. There are phenomena that behave very differently under dynamic situations than they do under static situations, but weight is not one of those. Mass is not one of those. Inertia is not one of those. Yeah. And then as far as your evacuated tube, I'm not sure what you've got planned. I'm imagining that what you're going to do is drop a ball inside an evacuated tube and measure the acceleration it experiences, the ball experiences within the tube, and from that you're measuring local g. And that's cool. That's awesome. If you can get one for a $50 price point, that would be fantastic. I'd be excited about that. yeah, I would want to play with one of those if it had decent accuracy, that it could measure, local gravity down to 1/100th of a meter per second squared. That'd be good enough, I think, to show the variation with latitude that we absolutely get with just regular scales. Let me also point out, while we're here, that there's a device called a gravimeter, I guess. It's called a gravimeter. Am I pronouncing that right? And we do have folks here in the science community, the debunking community, that use them professionally. They're used to in geology, and they're used like in mining to measure the specific gravity at a location. Like the local gravity vector varies throughout the Earth. This is a known thing. They use these things to measure how gravity varies to a very precise level in different locations to find density clusters below the ground. Like if there's a very dense mass below the ground, that could be an interesting ore or something like that, right? They can find that, or they can find a low density pocket. Like maybe there's a gas pocket that's low density or something like that. We could talk to some folks. There's folks here in the community that's their job, right? Is to use one of these things to measure how local gravity varies. They are quite expensive, from my understanding. So if you can make one for $50, that sounds exciting. I think that'll be a really cool thing to keep in the pipe, as you say. Let's do that.
Why are we always launching rockets east to west? To save fuel. Very good question. Now, okay, I can science that. He's only a young man. He wasn't around in 1969, and we all asked this question as well. And we asked that question was, oh, you're saving fuel. That's east-west direction. That's really good. Wow, this is really good. And then someone said, well, hang on. If they're really serious about saving fuel, why don't they just knock off that extra 300 kilos of ice hanging on the stage one of the rocket, and they'll save a lot of fuel. Because then you can take some more cameras and you can take some more video, so we can actually see that really good video that we all want to see. So, yeah, maybe you could, if you could answer that question for me, yeah, that would be good as well.
Sure. Let me start with answering your question. Why don't we just knock off the ice? The ice, why is the ice there? The ice forms because we have cryogenic fuels in those tanks. Very, very cold liquid oxygen, sometimes liquid hydrogen, things like that. With these cryogenic tanks, a lot of ice forms on them. So why not just knock that off? Yes, the ice is a burden. It's extra weight. We don't want that on there. We want that off. Why not just knock it off? Well, how do you propose to knock it off is the problem. The answer to your question is we would and do clear the ice when we can. And we've looked at putting heaters on the skins of the tanks, covering them with heaters to try to melt the ice off. It's just too much. We're adding more weight than we're taking off with all of this stuff. Most of it also does break away on launch. You'll see that a lot of it breaks away early on launch. You see that in the videos. So we want to get past that. Well, get the rest of it off. How are we getting the rest of it off? What are you suggesting? Get up there with a scraper? You scrape it and it reforms, right? So that's not going to work. We just haven't come up with a good way to clear that ice. We would if there was an efficient, cost-effective way to clear the ice that does not add more weight to the aircraft than the ice you're trying to remove. We would absolutely do that. Yeah, there's the answer to your question. Now, having answered that, let me point out that this strikes me as rather conspiratorial response to my question. Those aren't opposed to each other in any way. Also, just a correction, I think you just misspoke. We do not fly east to west, we fly west to east. Eastbound, right? The rockets launch out of Cape Canaveral in Florida, out over the ocean, right? We launch eastbound, not westbound. We launch eastbound with the rotation of the Earth. The Earth is rotating, presumably, right, towards the east. That's why the sun rises in the east. If the sun holds still, we want to go that way. So we launch with the rotation of the Earth on that.
And then they walk into the gift shop and you can buy a little 500mm pendulum that does the same thing. All right,
let's note that. Starting with the 500mm thing you buy in the gift shop. I had noticed that, so I went and looked. I went and looked online at some of these things. They are toys. Whether they claim to reproduce Foucault's results, that seems dubious. It seems to me as though the manufacturers of these things, the advertisers, the marketers, are sort of leaning into Foucault with this. They're saying, oh yeah, look, show how this works. Learn about science, they'll say. What they do not do is reproduce Foucault's result. They absolutely do not. They do not and cannot be relied on to do that. That was very clear. I watched some videos of people who had bought these things and played with them and really enjoyed them. They swing for a few seconds at best, and they leave a lovely trail, a very pretty pattern in the sand. They don't have precision launch mechanisms, and they don't swing long enough to show the precession, even if they were capable of showing the precession. So, no, these toys, these little tiny toys, are not acceptable at all for showing the rotation of the Earth that we're discussing. Although watching those videos did give me some clues maybe about what we're seeing with your results. I saw this fairly consistently, that these were launched by hand, and as they were launched by hand, they would do an oscillation. They would have like an oval shaped swing that you're very aware of. It's the death knell of a Foucault pendulum, is when you're doing the oval shaped swing. And the reason is because that oval changes shape as the pendulum progresses, and as it changed shape, you would see that they would also rotate very rapidly, and sometimes they would rotate out and come back, very much like what you were seeing. So I'm wondering if we're not seeing sort of the same thing in a microscopic scale. So that gives us something to look at. As far as the length of the pendulum, yeah, I think I agree with all of that. The longer the better, at least so far. The longer the better, the longer the more expensive.
Wilberforcing is quickly explained by a Wilberforce pendulum. The Wilberforce pendulum is a pendulum on a spring, and when it's swung, it randomly jumps around and does chaotic conditions. Now, you don't want your pendulum in any way experiencing random chaotic effects, and you'll measure it. You'll hang your plumb bob day 1 and come back in 4 days' time, and if it's grown in any length, you know you've got potential cable that could have a creep factor or that spring factor. So you have to get rid of that.
Okay, that made a lot of sense up until the end. Absolutely, the load is maximum at the bottom, and the tension in the cable will cause the cable to stretch, and you're going to get some up and down oscillation along with the side-to-side oscillation. And the frequencies of those oscillations may not match, and you could even get some chaos. We saw that in your demo, very chaotic, and chaos is going to be your enemy. Yes. And then at the end, you were talking about the like 4 days thing. In classical science, an elastic cable, purely a perfectly elastic cable, would not need 4 days to reach its maximum length. It would get there very, very quickly. Seconds, less than seconds, very, very tiny. You strain and stress, right? Strain and stress is just a linear relationship called Hooke's law. And for most materials within their elastic range, you're just looking at, it should happen right away. It should happen right away, not within 4 days. As far as the 4 days, wait for it over 4 days, now you're not looking at something that's going to bounce over the space of 4 days. If it stretches out over 4 days, now you're in the plastic zone of the material where it is deforming. The material is literally deforming under the load that you've applied, and I think at that point you've applied too much load. If it expands over the course of 4 days, yeah, I think you've overstressed your material if that's what's happening.
My cable is made from fibre optic glass. It has got zero creep. I have built in a magnetic detector that if the pendulum does experience Wilberforcing, it will actually detect.
Your cable is made out of fibre optic cable. That sounds cool. Yeah, that sounds like a good thing. It should not have any torsion as a result of strain, right? So that was the question somebody else had asked earlier. And also, your mounting point at the top, for viewers who haven't watched all of your stuff, it's actually it's a magnetic coupler at the top, and that is to minimize any kind of torsion in the mounting point. It's not just an eye bolt, right? It's not just like a twine hanging from an eye bolt, which obviously would have a strong bias to it. To eliminate the bias, Peter has put a magnetic mount up there and used fiber optic cable.
I can actually measure the precession of the pendulum with this indicator at the other end. And the measurements of this timber, this sliding timber, I'll give to him later if he wants it. So that's what I have for my precision angle measurement. However, I did find the laser more accurate on the wall, but I have an open mind to what his requests are, and hopefully this might help him out.
Okay, I'm curious about this. I really like where you're going with this. This is fantastic. What I don't quite follow is when you rotated the piece of timber, the laser did not rotate with it. And thus, how are you lining that up with the plumbob with any kind of precision? How would you, like, I'm imagining you're going to swing it, then as it's swinging, you'll rotate the wood to line up with it, and then we can measure what is the angle the wood is at. Maybe a little protractor on it or something, put some angle markings so we could see how that's going. How are you lining the wood with the plumbob? Maybe, just a thought, maybe if you put the laser on the wood, and maybe this is what you're doing already, if you put the laser on the wood, then you could use the laser to try to keep the plumbob swinging directly in the path of the laser so that you're using that to keep the wood lined up with the laser. Otherwise, what do we just do? Do an eyeball? Eyeball might be okay. I mean, I don't know. You probably have to tell me how well this works and maybe film it and we'll see. Okay, about the laser on the wall, I did some just back of the envelope calculations, and I don't think I can make that work. The laser on the wall, the difference is between the left deflection and the right deflection, if I'm understanding how that works, are too small to get any kind of precision out of it at all, or really to measure anything at all as far as the angle. So that's why I'm suggesting we should look for something else. Now just some final thoughts. Peter, obviously you've got some ideas about how these phenomena work that are different from what you might find in the textbook. And that's cool. That's super cool. But definitely I see in this a difference in motivation, maybe, a difference in how we perceive our relationships with this material and the people that represent this material. And to me, I find that really the most fascinating part of this discussion. In order to even ask the question, honestly, really assess the question, does a Foucault pendulum work like we're told it does? To truly embrace that as a question, we have to be willing to accept that foundational science, so much of foundational science is false. And that's quite the stretch. For me, that's quite a leap to make. To me, that brings home the idea that in order to be thinking in those lines in the first place, you already have to have a preconditioned mental state where you are not going to accept, or at least you are skeptical of, these foundational principles that we've had for hundreds of years. And that itself indicates to me that there's something has driven you to there. Something has brought you to where you are mentally now, with your relationship with mainstream science, right? And I think that is a really interesting question to dig into. How is your journey taking you to a place where you're ready to question that so easily, as compared to my journey, where I have continually been reinforced that no, you know what, the mainstream science has bumps along the way, but everything that I check, it checks out. Right? I keep finding confirmation. How has our journeys differed to bring us to these different places where we look at it? So that's really interesting to me. Other than that, the pendulum itself and your investigations with the pendulum are fascinating, and I will continue to follow this and continue to try to contribute, even if we find that your pendulum is it's doing nothing more than mainstream science says it should do. What your investigations are doing for us is digging into the pitfalls and the pros and the cons and the different kinds of ways that the rest of us could follow along and build one, right? When you finally get one that works, we could all follow along with your blueprints and build one that works as well, which is kind of what you're trying to do with Foucault's original blueprints. And on the flip side, if you discover a way to reproduce a pendulum that does not work, we can follow your blueprints and reproduce that ourselves too, and maybe discover something along the way. So what do we do now? Personally, I would really like to see a way to graph, the angle versus time, and it sounds like you're working on that. That would give us a better sense of what these things are doing. Do we get an initial rotation and then that rotation stops and then swings back. Is that what we get? Is that consistent? Is there an inconsistency to it, or is there a consistency to it? If there's any consistency to it, let's try to drive into what are the variables that affect that consistent result. Like, does metal versus non-metal have an effect? Does the amplitude of the swing have an effect? Does the length of the arm have an effect? All of these things we can test one at a time, and that's science, right? I hope many of you out there viewing and watching along this are going to follow as well, and keep a really positive, open-minded viewpoint to what these results might mean, and really how they might mean different things to different people, and that's okay. So I'll see you guys out there in the next video.